Well, hello, boys and girls. It's Mrs. Kohli. I'm really excited today to share with you a lesson. It's a science lesson about rocks and minerals. I mean, who doesn't like to study about rocks and minerals? They're everywhere around us. So today we're going to be using two or three different resources to help us study about rocks and minerals. The first thing is just a regular spiral notebook to take some notes in. Specifically today, I'd like you to be writing down some notes about what's the difference between rocks on one hand and minerals on the other hand. And then see if you can find some, try to make a Venn diagram here. As you do it, there's your Venn diagram. See if you can make some connections between things that are the same between them and things that are different as you try to organize your thoughts. The other thing that we're going to be doing is we're going to be working on our rocks and minerals book. If you have access to this paper, this printout, it's a great tool to use. However, not everybody has access to this. So if not, we can go ahead and take a regular copy paper and you would fold it into fours. So it looks like this. And this will become our rocks and minerals book. And then you can go ahead and open it up just as you would a regular book. And I'll show you quickly what it will look like. So you're going to have igneous rocks on one side, sedimentary, and then your metamorphic all on this page. And then if you take and you flip your book the other direction, let's see here. Then you're actually going to draw some pictures of these rocks on the inside. So as we're learning about rocks and minerals, you can be creating this book or the other book. This book, you're going to write down some of your favorite igneous rocks that you've learned about. On this page, you're going to write down some of your favorite sedimentary rocks. And on this page, you're going to write down your favorite metamorphic rocks and then summarize what did you like best about your study of rocks and minerals, just right here on the back. So I'll walk you through that step by step, and I'll also provide you a document of sorts, a PDF file that you can take and look at this information up close. So again, you're going to be creating a book that either looks like this, or you're going to color and write on the pages of this. So everybody has something that they can work on today. So let's go ahead and get started on today's lesson. Let's start big and then work to a smaller understanding of what rocks and minerals are. So if we were to look at like rocks on the largest scale that we possibly can, it would be looking at our rocks on planet Earth. So let's go through and talk about the different layers of our Earth. So it's just kind of like an onion. How if you were to cut into an onion, you're going to see that it has layers. Well, the Earth also has layers, and we live on the outer surface, which we call the crust. So the crust is where a lot of rocks and minerals are formed, just right here. And then we're going to go to our next layer, which is called the mantle. And if you were to drill, or if you were to just look for diamonds, you would find diamonds. In order to make diamonds, it's an organic material. We'll talk a little bit more about this, but it has to have a pure form of carbon in it. And it has to be put through a lot of heat and pressure to make it a diamond. So you can see the diamonds are found. Diamonds are minerals that are found with igneous and metamorphic rocks because it's a mineral that has to have other things with it, carbon and those kind of things, a natural pure form of carbon. And as an igneous rock, it's actually part of a rock group called the kimberlites. And so if people are mining for diamonds, they're looking specifically for that type of a rock. And just know that diamonds, in order to make that kimberlite, it has to be exposed to intense heat and pressure, which is why it is a type of crystal that is part of the igneous family. But because it does go through a lot of extra heat and pressure, it kind of also lends itself to the metamorphic family, but more so to the igneous family of rocks. The next layer of our Earth is called the outer core. And as you can see, I wrote some notes to myself. That's where it is in a liquid form, and it is composed of, or it's part of iron and liquid nickel. So we have liquid iron and liquid nickel in our outer core. And the innermost part of our Earth is called the inner core, and it has metal like iron and nickel in it, but it's a solid state there. So hopefully that helps with your understanding of what our Earth looks like inside and out, and where our rocks and minerals are formed. Most of them, like I said, are going to form right near the crust of our Earth. Okay. So what exactly is a rock? So this is what I would like you to write down in your spiral journal. A rock is a solid mineral material that's formed from parts of the Earth and other planet surfaces. All rocks are made of 2 or more minerals. So in order for it to be a rock, it has to have at least 2 or more of the minerals we're going to be talking about in it. But minerals are not made of rocks. So they are by themselves. They are created by themselves, but when added to another mineral, that's when we form our rocks. These are some names of rocks that we might see. Mountains have rocks. Boulders have rocks. Rivers have lots of little river rocks. We have stones, we have pebbles, we have sand, grain, dust, and speck. These things here are all part of the weathering process of rocks, isn't it? So we start large and we move to small forms of rocks. Okay, so then if we know what a rock is, then what's a mineral? Well, a mineral is a solid inorganic substance. It can be organic too if it has carbon in it. That is natural or not living. So it's not like an animal that has to breathe and has to eat. It is considered non-living. A mineral is the same all the way through. There are about 3,000 to about 4,000 known minerals on Earth, and all rocks are made up of 2 or more of these minerals. Good. So far, so good. Okay, so just really quickly, just know that minerals have a scale, and it's called the Mohs scale of mineral hardness, and it tells us which minerals break apart really easily, and which ones are more dense and do not break apart easily at all. So it's called the hardness scale, with talc being the softest and diamonds being the hardest. And typically what they do is they scratch from one to the other, and that will determine which one is harder. So some of the terms that we use when describing minerals, these are called the properties of minerals. We talk about its color, its luster, its streak, and its hardness. And again, this here shows you Mohs scale of mineral hardness. Okay, so if we talk about its color, most people think of color as an important characteristic of minerals, but it really isn't very useful in identifying minerals. Some minerals are nearly always the same color, but colors can change because of chemical reactions, heat exposure, and when air oxidizes it. These are some words that we use to describe the color of our minerals. It's dark or it's very dark, light, pale, pink, dull, shiny, and bright. Okay, if we're talking about the properties of minerals, we could be talking about its luster. That's the way that light is reflected off of the surface of the mineral. These would be the words that you would use to describe the luster of a mineral. Oh, it looks dull, or it's porous, it has holes, it's waxy, like a candle. Oh, it looks greasy or oily. It's pearly, silky, glassy looking, metallic if it's really shiny. Or you could say it's sparkly, shimmery, frosted, or milky. Those are all correct terms of describing its luster. Those are adjectives. Okay, if we're going to talk about the properties of minerals' hardness, again, this is the scale that I showed you just a few minutes ago. If something is very soft, you could take your fingernail and scratch it off with that, like what we looked at. Then there's different ways that you can find out if it's soft. If it can be scratched with your fingernail, scratch with a penny or a nail, And it gets harder if you can only scratch it with glass. It's really hard if it can be scratched with a concrete nail. And the hardest minerals that we have are diamonds. And because of that, diamonds are used to cut out all minerals, including diamonds themselves. Okay, now speaking about diamonds, diamonds are so interesting. They are truly the most expensive mineral out there that you can purchase because they're hard to find. They can be rare at times, especially if you find diamonds with certain colors. They're not all just crystal clear. Some are chocolate colored, some are like a rose pink colored, and then again, you're familiar with the typical just clear ones. So diamonds do have color. Also, based off of its luster, it will be more valuable or not. If it has a surface that looks a certain way in light, its value is higher. Also, streaks, what color is left when you scratch it against something, will determine, I guess, the rarity of that diamond. And then hardness, how hard is the minerals that are packed together. So, something to be aware of. Both coal and diamonds start off as an organic carbon element found in nature, but based off of how pure that carbon is and the type of heat and pressure that carbon is exposed to produces either a beautiful rare diamond or just some black coal that's used to produce energy. I remember that the byproducts of coal is energy, but it becomes these minerals, either coal or diamond, based off of the breakdown of like dinosaurs, plants, and those kind of things. That's the breakdown. As they break down, they produce carbon. And then depending on how that carbon is formulated, or where it is in the earth. Diamonds, again, typically are formed in the mantle of the earth. And so they're way down deep in the volcanic areas where there's a lot of heat and pressure. And then as it spews out with the lava and then the magma, that's what produces these rocks that are called the kimberlites that are formed as crystals. And so anyways, diamonds and coal are interesting. Just like with human beings, how do we handle things? When pressure's on, are we able to withstand the pressure and turn out like a beautiful diamond, or can we not succumb or deal with a lot of pressure, and are we going to end up like coal? So it's a very interesting thing when you study between coal and diamonds. And again, I'd rather have diamonds than coal any day, even though it's nice to have the heat produced from coal. So anyways, that's an interesting concept based off of when you put heat and pressure on minerals or on people, how do people react, or how do diamonds react, just if we wanted to personalize this to ourselves, make a connection. Okay, moving on. Now we're going to talk about types of rocks. So we are going to learn about the sedimentary rocks. Again, in order to be a rock, it has to have 2 or more minerals. Then we have the igneous rocks. And we're going to talk more about where these are formed. And then we're going to talk about our metamorphic rocks and where are they formed. Okay, igneous rocks, it means they're made of fire. So where do you think that they're going to be formed? And by the way, 90% of our rocks on Earth are igneous. Typically, they're found near mountainous regions, aren't they? So in order to be igneous, it has to have heat, and it comes from the flow of lava or magma from a volcano. Magma can occur by an increase in temperature, pressure changes, and or change in composition. So if you have an igneous rock, just know that it was formed somewhere in a volcano, or it could be near the upper surface of the earth, though, in the crust area, or it would be down like diamonds are, where they're being formed in the mantle area of the earth. Okay, these are some different types of igneous rocks that maybe you're familiar with. And again, some are harder than others. We have basalt and gabbro. I don't know how to pronounce all of these. We have obsidian, but granite, I would say, is probably one of the most common ones. And again, in order to find granite, typically people that are looking for granite to put maybe as foundation on homes or on beautiful buildings. This type of stone or this rock is found in mountainous regions. We also have pumice, which is very soft. So it's just interesting that some of these, depending on what kinds of crystals they have and the heat and the pressure that was put on them, determine, the hardness of those rocks. Okay, now we're going to talk about sedimentary rocks. Sedimentary rocks, it says, are layers of sediment in the ground that is being pressed together. Some of these rocks look like pudding with fruit, and they're called pudding stones. But these are some other samples of sedimentary rocks that you might see near you or in different areas around the world. So it says they are made when sand, mud, and pebbles get laid down in the leaves. Sedimentary rocks can be formed in deserts, lakes, rivers, and seas by rocks that have been worn down by wind, rain, and snow. So those are the key ingredients that help to form our sedimentary rocks. So sedimentary rocks are rocks that, because of weathering processes, they just chip off, break off, and then they're just kind of sloughed off and left as a remain in a riverbed, which is then taken to a lake or an ocean, and then just layer upon layer, it becomes like cemented and solid into like a concrete, and that makes our rocks that you see. So it's millions of years to make these rocks. Metamorphic rocks, so they are made by, let's go back for just a minute. On the sedimentary rocks, as you can see, there's our coal. So coal is just sloughed off from the remains of plants and animals that have died, and then it's just the layer upon layer will form the coal. Metamorphic rocks, so they are made by pressure or heat. They can be formed by pressure deep inside the earth or when they are heated up by an intrusion of hot molten rock called magma. They are often found in mountainous regions. Okay, so metamorphic rocks are also found in mountainous regions too. Metamorphic means changed in form. Examples include granite. Okay, so its examples include, if you have granite, which is igneous, the byproduct would be gneiss. So if you take granite, which is back here, if I take granite and then I apply heat and pressure to it, it's going to change to gneiss. If I take limestone, which is right here, a sedimentary rock, and if I provide, or if I put it through heat and pressure, it's going to change to marble. So it's really interesting that the rocks, they do go through a cycle, don't they? They're really recycled. So rocks can be changing their forms through the millions of years. So here's some different types of metamorphic rock. I talked to you a little bit about marble, but you can see that slate is right here. Oh, here's our gneiss that I was talking about. So this is, if you take granite and you apply it with more heat and pressure, it's going to change to gneiss. If I take my limestone and I apply heat and pressure to it, it makes marble. So interesting what can happen with rocks and minerals. So this is our rock cycle. And in my next video, I'm going to answer what this rock cycle would look like using our word bank of answers. We have metamorphic rock, igneous rock, sedimentary rock, magma, and sediment. Your job is to figure out what you think or where you think that those words would be based off of where they fall in the rock cycle. So that's your assignment to work on in answering those questions. And then I will show you the answers to that very soon. Now, if you're working on this book, it's going to have its own little rock cycle. You're welcome to color the pictures, and if you'd like to use some of my words to describe what happened during the rock cycle that you see here, you're welcome to do so. I went ahead and just made about a sentence in length describing what I saw happening on those pictures. So you're welcome to do that if you have the book. If you don't have the book, don't worry about it. You don't need to do it. So this is what your final product should look like. You could add a lot of cool color to these bubble letters. And this is page 1. It says, what is a rock? Those of you that do not have this, but you have this, You can jot some notes to yourself. But as far as what is a rock in the mineral, what is the difference between a rock and a mineral, all I asked you to do was just take and write this information in your spiral today. If you do not have this book, okay, I know it gets confusing if you have it, if you don't have it, but just for today's purpose, you are going to be having a quiz, and I'm going to ask you what's the difference between rocks and minerals. So it's always good to jot down some notes to yourself. So in your spiral notebook, or on just a regular sheet of paper, write down what a rock is and what minerals are. If you want to make a Venn diagram, and instead of writing sentences, just fill it out in a Venn diagram. That's always helpful too. Okay, so today's assignment is to understand what the difference is between rocks and minerals. And then if you'd like to save, stop the video right now. Then tomorrow or the next day that you'd like to work on this, you're going to be writing in your rocks and minerals book or filling out in this book the next thing. We need to know the 3 types of rocks and minerals. And so this is where you're going to, on one of your pages, write igneous rocks, sedimentary rocks, and metamorphic rocks on this page. And then on the inside, you can also do the same thing. This is where you're going to put your favorite rocks. You're going to write igneous rocks again, sedimentary, metamorphic. And this is when you can start drawing pictures of what they look like and what some of your favorite rocks would be. Okay, so this will be for day 2. You're going to focus on 3 different types of rocks, which we know are metamorphic, sedimentary, and igneous. And then if you're in this book, you're going to write down some notes about a diamond. That's a mineral. Diamonds are not rocks. They're called minerals. And you're going to use the properties of minerals to describe what diamonds look like. Again, if you don't have it, you can put that in your spiral notebook. Okay, and then for day 3, you're going to work on metamorphic rocks. You're going to write some notes to yourself. Day 4 is sedimentary rocks. And so again, if you have this book, you're going to write it here. If you don't have this book, you're going to write the information that you're learning in your little your little homemade book that you're making about rocks and minerals. So for day 3, metamorphic. So I have it happens to be on the back of my book. I would just write metamorphic rocks. I would write what it means. Maybe some examples that I told you about. Like I really like this where it goes from granite to gneiss and from limestone to marble. I thought that was amazing that it does that. So I wrote some little notes to myself. That's day 3. And then day 4 is about sedimentary rocks. And so I put that right here. And I just wrote down some notes to myself. Some of the things that I would remember about how they're layered. And if you want to write coal, you can write coal on there. And then for day 5, you're going to be writing about igneous rocks. And so on this book, I put it right here, igneous rocks. I said that they're made of fire, and I said 90% of rocks on Earth are igneous rocks. Try to put at least two sentences. I wrote a lot more than I needed to, but why don't you choose your favorite 2 sentences? So this is day 5. Day 6 is going to be, okay, that is the end of that. So day 6 is going to be when you actually work on your rock cycle. So you could color this for day 6, or if you don't have that to color, then you're going to, for day 6, you're going to come back here. You're going to complete this. And so I'll have this as a PDF file. So this will be for day 6. And I'll have a video to go with day 6. I hope that this is going to be a lot of fun as you're learning about rocks and minerals, and as you're taking your knowledge and you're applying it to your everyday life. You can go outside and you can go on a hunt and you can try to find these kind of rocks. Let me come back here. So you can take the rocks that you find just laying on the road, or you can go on a hike somewhere and start to be like a geologist. Geologists like to study rocks and rock formations. And you can start your own little study about, well, what do I think this is? And start to collect maybe igneous rocks metamorphic rocks, and sedimentary rocks. And you can start to label them using this information that I provided you with. Also, you can check out a lot of great books from a public library or maybe your school library, or you can watch some great videos on YouTube to help you to understand as you collect your rocks, what rocks you might have collected too. So I hope you enjoyed this lesson. I hope you found it valuable. And I hope you have a lot of fun as you're creating, whether it be this book or this book. Happy reading, happy writing, and just keep on smiling. Have a great day. Until next time, bye-bye.